Okay, good morning, everyone. Okay, as we discussed, today we are going to discuss vector tube, MCQ tube. I think all of you have done this, no? Hmm? Have you completed this? Tell me that one. Have you completed all the questions? Hmm? So I read your responses. I'm asking about MCQ questions in vector tube. Hmm? Did you complete that? I will let you know, Muta. You can get the soft copy. If you may want to get the hard copy, please let me know. I will send that to your address. Okay. Then you can pay the required delivery charge for that delivery company, and you can get the hard copies. Okay. Otherwise, you can take the printouts. But I think hard copies it is much cheaper. Okay. Oh. Berapa barang aja lah kerada. Okay. Shall we discuss MCQ with you? Have you completed? No? Oh, I need your response, Asputa. You have to give a simple answer. If you completed, yes. Otherwise, no. Yes or no. There are, yes, 8. It means 6 students. Okay, I will ask one by one. Hiruni, have you completed? No. Jasmine? Rashidi? Couldn't complete all, no? No, not all. Cannot say that. I take that. Oh. නෝක තමයි වලින් ඕගොල්ලෝ වල පස්සේ ඉන්නේ සිංහල විදිහට ළමයි එහෙම නෙවෙයි. ඒගොල්ලන්ට කිව්වම යමක් කරනවා. ඇත්තමයි. හරි. සිංහල මීඩියම් දරුවෝ ටික මේ එක දවසක් මම කිව්වේ ක්ලාස් එකේ මම කරන විදිය. ඊළඟ දවසේ යනකොට කට්ටියම කරලා තිබ්බට උත්තේ. හරි. කට්ටියම කරලා. හරි. ඒ කියන්නේ මට හරි ලේසි තිබුණා. මට ලේසි කියලා කියන්නේ මට ආන්සර්ස් ටික ඩිස්කස් කරන්න දී ඇසර කලුටින් කරන් දෙන්න වෙලාවක් ඕනේ නැහැ. හරි. ඒක මොකද? හරි කරලා මොකද ප්ලෑන් එක අවුට් කරනවා. හරි. මම මේක ඔයගොල්ලන්ට කරන්න කිව්වේ then last week එකක් කරනවා ඊට කලින් previous week එකේ කිව්වේ. හරි. So actually I have asked to do it. Okay. Anyway, actually there is a method to do MCQ tubes. We have discussed that thing in our previous class. How to do a MCQ tube? Again, how to do MCQ tube? There are only 56 questions, Puta. There are only 56 questions. So I ask you to do all the questions at once. Don't do one half at another one day and another half in another day. Don't do that. Okay? Because you have actually you should improve your timing. Okay? You have to allocate only 2 hours. You have to allocate only 2 hours for this MCQ tube and complete all the questions within that 2 hours. If you cannot do that, then please note how many questions you did within 2 hours. Within 2 hours. Okay. Because you have to improve your question timing ability. Okay. Therefore, don't do one by one. Okay. One by one. You have to do these questions at once. At once means you have to allocate 2 hours you have to allocate 2 hours for this tube. Then you can do all the questions within that 2 hour, because there are only 56 questions. 56 questions means 2 minutes per one question. 2 minutes to one question means nearly, it is nearly 2 hours. Okay. Don't put 2 minutes, but in your LLMCQ, there are only 50 questions. No? Therefore, 50 and 56 is very near numbers. Therefore, allocate only 2 hours. Allocate only 2 hours for this tube. Then do all the questions within that 2 hours. Actually, we have discussed this thing. Okay. I mean, දැන් ඕන මේ ක්ලාස් එකට එනකොට ඊට කලින් දවසේ රෙකෝඩින් එක බලන්න මොකද කරේ කියලා බලලා එන්න. හරි. එහෙම නැතුව නිකන් නම් එන්න එපා. හරි. ඕකේ. එනදී මේ කලවඩක් නෑ නේ. එකකට කළා නෑ. එහෙනම් අපි මේ ෆෝස් වීක් එකෙන් පටන් ගමු. මම එක කැමති නෑ ඒකට. මොකද කැමති නෑ කියලා කියන්නේ ෆෝස් වීක් එකෙන් කතා කරන කලින් මේ ටික කතා කරා නම් හොඳයි කියලා මට හිතෙනවා. ඒක මම සාමාන්‍යයෙන් කරලා සිංහල මීඩියම් ක්ලාස් එකේ මම දවස් දෙකක් කරන් දවස් දෙකක් ගියා තමයි ටියුටර් කතා කරන්න. මොකද ක්වෙස්චන්ස් තියෙන ගොඩක් තිබ්බා ළමයිට. හැබැයි මේ ක්වෙස්චන්ස් තියෙන මේ නැති ගන්න තමයි මම ඕගොල්ලන්ට මුලින් මේ අර ඇප්ලිකේෂන් එක කියා දුන්නා. ඇප්ලිකේෂන් කරන්නේ කොහොමද කියලා කියා දුන්නා. කියා දීලා කරන්න කිව්වේ ඒකයි. ඒක කළා නෑ. හරි. Okay. Shall we move to force equilibrium? Shall we move to force equilibrium? Then, if we have enough time to do this MCQ today, we can do that. Okay, I will share the tute within the group. Then you can download that tute and allocate 2 hours. Then do the tute within this class. Okay, class again. Okay. Let's start to do force equilibrium. Okay. Additional පොතක් ඕනේ නැහැ. ඔය vectors ලියන පොතේම ඔයා මේ ලියු කරන්න පොතේ මේ පිටුවක් දෙකක් විතර ලියු කරලා අලුතෙන් ලොකු heading එකක් දාගෙන ඒක ලියා ගන්න. ඒ කියන්නේ suppose this is your vector book, and if you complete vector note here, then you can leave this page, or then you can write the topic of this, the main topic, that is force equilibrium here, and don't write anything in space. Then you can start writing from this page. Okay, therefore you do not want to buy additional book for force equilibrium, because force equilibrium also force equilibrium is categorized under static lesson. Therefore it is correlated with vectors. Okay, then shall we move to do force equilibrium? Motion graph will be no, it is another name. Tomorrow. Motion graph is tomorrow. Okay. Okay. Force equilibrium. Normally, actually, we have discussed about mechanics unit. Mechanics unit mainly consist of 3 categories, 3 subcategories. What are those? The first one is static. Second one is kinematic or dynamic. Third one is fluid. Fluids. Okay. Static means learning about stationary objects. Or stationary object means objects they are not moving. Kinematics. So dynamics means it is a study of moving object or dynamic objects. Fluids means it is a subject about fluids. Okay, fluids. So it's static. So force equilibrium is categorized under this subsection, that is static. So this is static lessons as well as vectors. Okay, so this is a static lesson. Okay. Therefore, you have to write this one in your static book. Okay. You have to maintain 3 separate books for mechanics, static, kinetic, and fluids. Okay. So you can write these notes in your static book. Static. Okay. Okay. Now we are going to discuss about force equilibrium. Everyone listen to me very carefully. This is very important lessons because this is actually this is about vectors as well as geometry. Therefore, this is very important lesson. You have to understand the theory part very well. Otherwise, you cannot apply that thing to the question. So please listen to me very carefully. Right? Other thing is you have to understand the basic concepts very well. Okay. Otherwise, don't go for the questions. Don't go for the questions. You're doing questions because you have to understand the theory part very well. Okay. Okay. Force equilibrium. Write a topic. Force equilibrium. Now, before doing force equilibrium theory part, actually, we have to get some understanding about the force. Or what is a force? And what is a force and what is the definition of force? We have to understand that part first, because now we are going to study about force equilibrium. Look at the arguments. Look at the arguments, Puta. You have to understand those arguments very well. We are going to study about force equilibrium. Therefore, we should get some idea about force. Okay. To get an idea about force or to get some understanding about force, we have to understand about mechanical states of an object. Mechanical states of an object. What are the mechanical states of an object? Shall we discuss that? Okay. Mechanics. Mechanics means mechanics about some mechanical things. That means, suppose you are going to learn about some machine. Okay. If you want to learn some machine, there are a lot of parts here. No, some parts are moving. Some parts are moving. Some parts are not moving. It is in stationary conditions. Some parts are moving. Moving in rotation. There are rotational movements. The linear movements, simple harmonic motion. Therefore, if we may want to learn about machines, there are a lot of movements. There are a lot of movements. Some machines, some parts are moving, while others are not moving. If we consider about moving objects, that movements can be a linear motions, rotational motions, the vibrations, the simple harmonic motion, that kind of motions can be happen. Therefore, if we consider about a machine, there are a lot of Mechanical parts. There are a lot of mechanical parts. This is an example. Okay. If we consider about machine, there are a lot of mechanical parts to that. Some mechanical parts are not moving. That means they are at the stationary condition. Okay. Still condition. They are not moving. Some parts are not moving. They are in stationary condition. No? Then some parts are moving. No? Other parts are moving. If we consider machine, some parts are at the stationary condition while the others are moving. No? If you look at the moving objects, you can clearly see there are some movements where there are some movements in straight line. That means some linear motions. There are some linear motions. No, there are some linear motions. Some parts are moving in a circular path, circular motions. Some parts are rotating about axis, which is going through its own body. Those are called as rotational motions. So there are some rotational motions. There may be rotational motions. There's simple harmonic motion. You will study about that simple harmonic motion. Therefore, if we consider about motion, there are a lot of motions. Okay. So if we take a machine, we can categorize its parts into two main categories. What are those? Some parts are at a stationary condition, other parts are in moving condition. Therefore, if we consider about mechanical behavior of a body, of an object, if we consider about mechanical behavior of an object, we can state there are two, actually we can say there are two states. What are those? That object may be at stationary condition or moving condition. Okay. Those are the two conditions of an object. Those are two mechanical states of an object. Okay. Either it can be a stationary object or a moving object. Okay. Okay. Right topic. I think do you have any questions about that? Or do you get my point? With respect to mechanical behavior of an object, we can categorize two states of an object. Okay, either it is in stationary or moving conditions. Okay. Okay, right topic. Mechanical states of an object. Mechanical states of an object. Mechanical states of an object. Mechanically, an object can have two states. The first state means the first condition is it can be a stationary object or it can be a moving object. The first one is at rest. The second one is moving state. Okay. Still, I'm not going to discuss about force, okay? But in the main, okay. Look at the arguments. Look at the arguments. The arguments from the so my first point is the mechanical states of an object. There are two mechanical states. Some parts can be at rest, while the others can be they can have a movements. Okay. Okay. Then we are going to discuss about constant state condition. Constant state condition. Constant state condition. You know about state now, no? There are two states. What are those? What are those? At rest or stationary condition. Second one is moving condition, no? Second one is moving condition. Okay. Moving. Okay. If these two conditions are not changing with time, if those two conditions are not changing with time, that means we can say it's a constant condition, constant state condition. That means, suppose this object now is at rest, no? Suppose this object is at stationary condition for 10 seconds or for 1 minute, for 1 minute time period. Then we can say this object has a constant state for 1 minute. Okay? Did you get my point? What is a constant? Did you get my point? What is a constant state condition? Constant state condition means its current state is not changed, is not changing with time. Time එකක current state එක change වෙන්නේ නැත්නම් අපි කියනවා ඒක constant state condition එකක් කියලා. Did you understand that one? Everyone, I need responses. Okay, others? Others? Thank you. Thank you. So, if any object does not change its current position, current condition with time, that object has a constant state condition. Okay. Suppose if an object is at rest and its current condition does not change with time, that means that object is still at the rest, no? Therefore, its current condition is not changed. Then suppose if any object has a movement, this has a movement. If its current condition is not changing, then what kind of motion is this? If suppose there is an object, now it is in a motion. It is in a motion, or it is moving. If this object has a constant state condition, if this object has constant state condition, then what kind of motion is this? Motion. Yes, very good. with a uniform velocity. Its velocity cannot be changed, no? Look at this. Look at this. Now this object is moving at 10 ms minus 1. 10 ms minus 1. So, if this motion is not changed with time, so this velocity cannot be changed, no? This velocity cannot be changed. It should be a constant velocity. Okay? Otherwise, its motion is still no. Therefore, if any moving object has a constant state condition, if any moving object has a constant state condition, its velocity should be a uniform velocity. Uniform velocity. Velocity cannot be changed with time. Okay. Did you get my point? Everyone, I need responses. There or another?
Yes, sir.
Others? Thank you. Thank you. Therefore, if any object has a constant state condition, it can be either at rest or moving with the uniform velocity. Uniform velocity. Okay. Write the thing. If no, sorry. Topic. Constant state condition. Topic. You should write that topic. Constant state condition.
It's a subtopic, right?
Sorry?
It's a subtopic, right?
Subtopic. Constant state condition. Yeah. Okay. Right under that. Right under that. If the above two states do not change with time. Do not change with time. Then it is said to be then it is said to be constant state condition. Constant state condition. Okay. 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 If we consider an object mechanically, it can be at rest or moving. Rest or moving. Those are the two conditions. Okay. This is v equals 0. V equals 0 means v means velocity. Velocity is equals 0 means it is at the rest. Okay. So if what does it mean? What does it mean? If the velocity is 0, t equal 0 to t equal t equal 0 to t equal t means time. 0 to time t. That means within that period, this object has a constant state condition. Within that period, this object has a constant state condition. Suppose this is t equals 0, that means initial stage, and this is t equal t again, t equals 0 to t equals to t equal t. That means initially it has 10 ms minus 1 velocity, and for this time period it has that uniform velocity. That means the velocity of that object does not change with time. Therefore, we can say this object has a constant state condition. Okay. Okay. Draw this one. Okay. Right under this, right under this. Look at this. If you cannot see clearly, please let me know. In here, the object has a constant state condition for t time period. The object has a uniform velocity for t time period. The object has a uniform velocity for t time period, and right under that, this column, okay, this column, right under that. Therefore, it has a constant state condition. It has a constant state condition. Therefore, it has a constant state condition. Okay, right under this figure, right under this figure, in a new paragraph, okay. Therefore, if an object has, a constant state condition, either it should be at rest, or it should move with a constant velocity. It should move with a constant velocity. Okay. Then up to now, do you have any questions? First, we have discussed about what are the mechanical state of an object. Mechanical, if you consider the mechanical behavior of an object, so what are the states of an object? Then there are two states. What are those? Stationary condition or moving condition. Okay, moving condition can be classified further into subcategories, but we are not going to discuss about that at this point. We will discuss about that. Then we have discussed about what is a constant state condition. මේක පොතේ මතක තියාගන්න මේක arguments වලින් යන්න ඕනි subject එක. Okay, so you have to have very clear understanding about each and every arguments. Okay, then my third point, what is a force? What is a force? Tell me an answer. Give me an answer. What is a force? I need responses from everyone, okay? I don't want to get the correct answer, but you have tried. This force is a vector. That is correct. Another one?
The product of mass into acceleration.
That is another one. Another definition or another another definition. Both are correct, both are correct. Pull or push, yes. That is also correct. Pull or push. Any other definition? Good. All of you are correct. All of you are correct. But we have to understand, actually, we have to understand very clear about the force.
So it's the ability to change the state of an object.
Sorry about
It's the ability to change the state of an object.
Very good. Okay. So actually, force is an external factor that can be changed the current condition, current mechanical condition of an object. Okay. So that is the definition of the force. We can determine force using your definitions that we call and make. Then force is a vector also. It can be defined. It can simply define as pull or push. Okay. Anything. Therefore, all are correct. But the correct definition means the force is an external factor. Look at this external factor. Okay, external factor that can be used to change the current condition or present situation of an object. Current condition means there are only two conditions, Buddha. No, there are two conditions. What are those? Either rest condition or moving condition. So if we apply a force on an object, if I exert a force on so to an object, its current condition will be changed. That means we can move. Suppose there is an object which is at rest. Now this object is at rest. So I can move this object by applying a force. Okay? By applying force. So initially it is at rest. Initially it is at rest. It was at rest. Okay. So if I apply an external force to this object, this condition will be changed. Same thing happened to a moving object. So if I apply a force into this object, what will happen? Its moving condition will be changed. That means its velocity can be changed, the direction of velocity can be changed, anything, the magnitude of velocity can be changed, the direction of velocity can be changed, its moving condition can be changed. Therefore, the force is an external factor that can be used to change the current condition or current state of an object, current mechanical state of an object. Did you get my point? Did you get my point? Okay. So that is the definition of a force. Okay. Okay. Write a topic. Write a topic. What is a force? What is a force? What is a force? I don't know. It is a topic, not a question. It is a topic, not a question. Okay, right under that topic. The force is an external factor, that can change the current state of an object. Sorry. Everyone listen to me. Actually, you have to understand this definition very clearly, because we have a lot of questions to evaluate the definition. Okay, therefore, there is very famous question. You have to understand that definitions very clearly. So if we apply a force to an object, its current condition will be changed. If its current condition is not changed, or if its current condition is not changed, that means there won't be any external force. Okay. Right in a new paragraph. That means if an object is at rest, if an object is at rest, we can move it. We can move it. We can move it by applying an external force. By applying an external force. If an object is moving, if an object is moving with a uniform velocity, its velocity can be changed. Its velocity can be changed by applying an external force. Sorry. By applying an external force. Okay. හොඳයි. මම අර ඔයගොල්ලන්ට කලින් කිව්වා මම මේ සිලබස් එක කඩාගෙන තියෙන්නේ මුතේ logically හැමෝටම එක්ස්ප්ලেইন කරන්න පුළුවන් විදිහට. එහෙම නැතුව ඔයගොල්ලන්ගේ සිලබස් එකේ දීලා තියෙන පිළිවෙලට නෙමෙයි ඒක මහ ගොම් විදියක්. හරිද? ගොම් විදියක් කියලා කියන්නේ වෙක්ටර් වල කෑල්ල ලකු ගන්නවා එක තැනක ඊට පස්සේ ආයි ලීනියර් මොෂන්ස් කෑල්ල ලකු ගන්නවා ඊට පස්සේ ආයි මැද්දේදී මේ රිසල්ටන්ට් ෆෝර්ස් එක හොයනවා ඊට පස්සේ ෆෝර්ස් ඉක්විලිබ්‍රියම් කොටසක් කරනවා ඊට පස්සේ ආයි මේ ආයි යනවා මේ ඩයිනමික් එකට ඔය වගේ මහා මොහ විකාරය. ඒ නිසා ඒකේ පිළිවෙලට උගන්වන්න ගියොත් නම් ඕගොල්ලන්ට මිලෝ මොකද තේරෙන්නේ නැහැ. හරි. දැන් අපි ඊළඟ ලෙසන් උත් එහෙම දැන් වීට් වගේ සංඥා ගත්තොත් එහෙම තනි කරම අල්ලලා තියෙනවා. හරි. හීට් එක කියන්නේ මොකද්ද? ටෙම්පරේචර් කියන්නේ මොකද්ද? ඔය දෙක අතර තියෙන ඩිෆරන්ස් එක මොකද්ද? ඒ කිසිම දෙයක් උගන්වන්න නැතුව මුලින්ම උගන්වන්න තියෙනවා මේ තර්මෝමීටර්. මේක තර්මෝමීටර්ස් කියන්නේ. තර්මෝමීටර්ස් කියන්නේ ළමිට උගන්වන්නේ කොහොමද? අද උගන්වන්නේ නැති. හරි. ඔයාලට තේරෙයි උගන්වනකොට තර්මෝමීටර් ගැන උගන්වනකොට අනිවාර්යෙන් අපි ළමයට කියලා දෙන්න ඕනේ හීට් එක කියන්නේ මොකද්ද? ටෙම්පරේචර් කියන්නේ මොකද්ද? ඔවා ඩිෆරන්ස් එක මොකද්ද? ඊළඟට මේ කොහොමද? කොරිලේට් වෙන්නේ කොහොමද? ඒව කරලා ඊට පස්සේ එක්ස්පැන්ෂන්ස් කරලා මේ හීට් කැපැසිටිස් ගැන කතා කරලා ඔක්කොම කරලා තමයි එන්න ඕනේ මේ තර්මෝමීටර්ස්. මොකද තර්මෝමීටර්ස් වල කතා කරන ඕනේ ඔක්කොම. හරි. මේ ඔන්න කතන්දර ඔක්කොම කියනවා. ඒ කියන්නේ කිසිම දෙයක් පිළිවෙලට නැහැ. ඔයාලට දිගටම ඔයගොල්ලෝ තියෙනවා. මේ ෆිසික්ස් කියන සබ්ජෙක්ට් එක ගොඩක් වෙලාවට ළමයින්ට තේරුම් ගන්න අපහසු වෙන හේතුව ඕක. හරිද? මොකද කවුරු හරි ගුරුවරයෙක් ඔය මේක ෆලෝ කරොත් එහෙම සිලබස් එක ෆලෝ කරොත් එහෙම ජීවිතේට තේරෙන්නේ නැහැ ළමයින්ට. කොච්චර හොඳ දෙයක් ඇහුවත් තේරෙන්නේ නැහැ. හරිද? ඒ වෙලු ගන්න එක තේරුම් ගන්නවට සම්බන්ධයක් ගොඩනගන්න බෑ. හරි ඒක. ඒ නිසා මේක ලින්ක් කරලා උගන්වන්න ඕනේ. ලින්ක් කරමින් තමයි මම උගන්වන්නේ. ඒක නිසා මම ඒක මුලින් වෙක්ටර්ස් ගොඩක් ඩිස්ක්‍රිප්ටිව් විදිහට කරේ. වෙක්ටර්ස් අපි රිසර්ච් පාන්නේ මම හිතන්නේ 15 number of lessons කරානේ. හරි. මේ තරම් අපි ඩිස්ක්‍රිප්ටිව් විදිහට කරා. ඒ ඩිස්ක්‍රිප්ටිව් විදිහට කරේ මේ ඔක්කොම පෝස්ට් ඉක්විලිබ්‍රියම් මෙතනදී තියෙන ඒවත් මම කතා කරා. හරි. එතකොට ඒක කරේ මේකට මේ ලින්ක් කරන්න ඕනේ. දැන් ඒකෙන් මම මේක ලින්ක් කරනවා. ඒ නිසා දැන් ඔයගලන්ට වෙක්ටර් නොලෙජ් එක පුයි තියෙන්න ඕනේ. වෙක්ටර් නොලෙජ් එක පුයි තියෙන්න ඕනේ. මම ආයෙත් මේක ඇතුලේ වෙක්ටර්ස් කතා කරන්නේ නැහැ. හරි. එතකොට මගේ අර ලින්ක් එක තනිකරම කැඩෙනවා. මෙන්න මේ හේතු නිසා මේක මෙන්න මේ හේතු මේක මෙන්න මේ මම ලොජිකලි අරන් යන්නේ. හරිද? ඒ නිසා ඒ ලොජිකල් වලට දාගන්න නැත්නම් ලොජිකල් වලට දාගත්තේ නැතුත් තියෙන මුල මොකද තේරෙන්නේ නැහැ. හරි. Okay. Now we have done some subcategories of force equilibrium topic. The first one is we have discussed what is a mechanical states of an object. Then we move to constant state condition. Then after learning that part, we have defined force. Okay? So those are categorized under a logical some kind of algorithm. Okay? Therefore, you have to logically understand one by one. Right? Then we can move to the next session. What is that one? Newton's law. Newton's law. Actually, the force is defined by Newton's first law. Okay. Now we are going to learn about Newton's law about force. About force. Write a topic. Write a topic. Newton's law of motion. Newton's laws of motion. Newton's laws of motion. Sorry. No, the topic is Newton's law of motion. Newton's laws of motions. We are going to discuss all the three laws. All the three laws very descriptive. Okay. And therefore, now I am not going to discuss about. Not going to write about laws. Okay. This is not a writing. Okay. Now I am going to explain that. What is that law? What is the basic theories? So basic theories which is which are discussed under that law. Okay. Now we have to get fully understand about that thing. Okay. Initially, okay. Now we are going to discuss about Newton's law. The first thing is Newton's first law. Don't write anything. Don't write anything. What is Newton's first law? Tell me. Tell me. Very good. Others? 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 What is Newton's first law? Okay. There are three laws of Newton's regarding motion. Actually, Newton has discussed about force in these laws. Okay, in these three laws. So, what is the first law? Yes, and yes, very good, very good, very good. Two answers are correct. Tell me another thing. Okay. So, what can you get from Newton's first law? So, what is the outcome? What is the outcome, or what is the what is the outcome of the Newton's first law? Tell me. And again, look at the outcome again. Okay. Yes. Very good. Okay. When you are going to understand about a law or theory, you have to have very good understanding about each and every terms in that theory or law. Okay. In Newton's first law, what is the Newton's first law? Until an unbalanced force is applied on an object, its current condition won't be changed. Or it is at rest, or it may moving at a uniform velocity in a straight line. That is the law. Until an unbalanced force is applied on an object. What is that? What is that thing? Until an unbalanced force. So, what is the meaning of unbalanced force? What is that? What is that? What is the meaning of unbalanced force? Now you are going to describe Newton's first law, Putta. If you want to describe Newton's first law, you have to have very good understanding about each and every term in that law. Okay. According to Newton's first law, until an unbalanced force is applied on an object, it will remains at rest, or it will move at a constant velocity in a straight line. Okay. So what is the meaning of unbalanced force? Unbalanced force. Actually, it should be external unbalanced force, not unbalanced force. Until an external unbalanced force. It should be an external unbalanced force. So, what is the meaning of external unbalanced force? 10. Oh, Uninterrupted responses.
A force that doesn't balance with the other forces acting on the object.
Sorry, Putha?
A force that doesn't balance with the other forces acting on it. That means where it will give a resultant.
Yes. Very good. Yes. Good. And external unbalanced force means externally applied force which is resultant is not equal to 0. No? So there may be single force or force system. There may be a single force or a force system which is resultant is not equal to 0. That is external unbalanced force. Look at this. Suppose this is an object. This is an object. If I apply 5 Newton here, is this a external unbalanced force? Yes or not? Is this an external unbalanced force? External unbalanced force?
Yes, sir.
Yes.
Yes.
Suppose now there is a 5 Newton here and another 5 Newton from here. Now, what is the condition? Unbalanced condition or balanced condition?
Balance condition.
Balanced condition. It is a balanced condition. 10 Newton, 5 Newton. Now, is it
Unbalanced.
unbalanced? So external unbalanced force means this force should be applied externally. External, not internal. What is internal? Are there any internal force? Yes, there may be. Because there may be some nuclear forces. Those kind of forces can be categorized as an internal force. So we are not discussing about that kind of forces. We are discussing about externally applied forces. Externally applied forces. So all of them are externally applied forces on this object. That is the first thing. Externally applied forces. Then externally, the unbalanced force. Unbalanced means there should be a resultant. There should be a resultant. So these two forces are external forces, but those are equal and opposite to each other. So there won't be any resultant force here. Therefore, this is called external unbalanced condition. So what Newton's first law? Newton's first law is discussed about first, two, and three. Which condition? First condition or second condition or third condition? Tell me. In Newton's first law, he's discussing about the first condition or second condition or third condition. What is the condition? He discussed about. What condition if they discussed in Newton's first law? Others? He discussed about second condition, not the first one, not the third one. He is discussed about second condition. That's why I may ask you to understand very clearly. Okay? You have to understand very clearly. He's discussed about second condition, not the first one, not the third one. But he said it has some reverse method. Okay? Reverse what does he say? He said until an external unbalanced force is applied on an object. That means until an unbalanced force means the unbalanced force is not applied. It is not applied. Okay? Until an unbalanced force, until an external unbalanced force is applied on an object. Until is there. That means an unbalanced force is not applied yet. So it should be at balanced condition now. Balanced condition. It should be at either balanced condition or there won't be any forces. Right? Really? So in Newton's first law, he said about, or he's discussed about the second condition. Until an unbalanced force is applied on an object, until an unbalanced force, until an external unbalanced force is applied on an object, the object is at the rest condition or moving at a constant speed on a straight line. That is the law. That is the law. So look at this one. Until an unbalanced force is applied on an object. Until an unbalanced force means the force is applied, is not applied now. Okay? Force is not applied. Okay? Therefore, Newton's first law is discussed about the second condition. Second condition means if there are external forces, those should be balanced or there won't be any force. There won't be any force. Fair enough? Sorry, did you get my point? Everyone, I need responses. Okay. Therefore, Newton's first law is discussed about if there when the object, when an object is at balanced state or no force state. Those are the two states which are discussed under Newton's first law. Okay. මේක කියන්නේ මේක දැන් අපි අර ඒ ලෝල් ඉගෙන ගත්තා වගේ පොඩිට නෙවෙයි කරගන්නේ. ඒක ඩිස්ක්‍රිප්ටිව් විදියට එකින් එක යනවා පුතේ. ඒකයි කියන්නේ මේක හරියට මොළුට දාගන්න ඕනේ. හරි. Okay. Right, the topic. The first topic is Newton's laws of motion. Then the first subtopic is Newton's first law. Newton's first law. Okay. Write the Newton's first law. Write the Newton's first law. And මුලින්ම අපි Newton's first law එක ලියාගෙන එක කොටු කරගන්න. ඊට පස්සේ අපි terms ටික වෙනම discuss කරමු. Okay. Okay, මේක ලියලා කොටු කරගන්න. An object at rest, remains at rest. an object at rest remains at rest. And an object is in motion an object is in motion remains in motion at a uniform velocity at a uniform velocity on a straight line on a straight line unless at unless act on by an external unbalanced force. An external unbalanced force.
So unless
act on by an external unbalanced force. Act on by an external unbalanced force. Unbalanced force. මම පොඩක් අනිත් පැත්තට දුන්නේ ඕගොල්ලන්ට ඔයගොල්ලෝ ඕලල් කාලේ මතක තියන් හිටපු ලෝ එකකට පොඩක් අනිත් පැත්තට දුන්නේ ඒකට හේතුව මේ දැන් එතකොට ඕකෙන් බලන්න ලෝකේ දින විදිහේ අපිට කියන්න පුළුවන් අර මොනවාගේ conditions දෙක will remains constant unless an unbalanced force is act on an object. Okay, now we are going to describe each and every terms in that law. Then we can fully understand about that law. Okay. No. Even the object in uniform velocity was no. If we have discussed about the thing now. If there are two states, no? First, two constant states. What are those constant states? First constant state is at the rest, no? Stationary condition. The second one is moving at a constant velocity. So if the current state of an object is not changed, that means there won't be any force. If its states if its current state is changing, is being changed, that means there should be a force. Okay. So if an object is moving in a uniform velocity, definitely there won't be any external unbalanced force. Okay. There may be this kind of external forces. There may be this kind of external forces, but there should not be unbalanced force. Unbalanced force. ඒක හොඳ question එකක්. ඒක හොඳ question එකක්. Because there may be some questions where some තියෙන්නේ මොනවද? මොනවද? Yeah, thank you. But that question is very good question, Pudha, because there may be some state, there may be some 3 states questions. අපි කියන්නේ අපි දෙන්නේ මේ right or false of behind the questions team. So there may be some question, something, suppose you are asked this kind of question. So suppose if an object has a uniform velocity, then there should not be any force acting on that object. Is this correct or no? Correct or wrong?
It's wrong.
If,
It's wrong.
it wrong. Why?
So because if you take a car, sir, it can go on the same, so like in the same speed, but a force is acted on it because we have friction working against the.
Yeah. Actually, if an object is moving with a uniform velocity, actually there may be forces or not, but there should not be an unbalanced force. Unbalanced force. Okay. So if an object is moving in a uniform condition, uniform velocity condition, definitely it may not having a external force, or if there are external forces, those should be balanced. Okay. Therefore, if an object is moving at a constant speed, there may be forces. If there are forces, those forces should be balanced. Those forces should be balanced. Balance වෙලා constant speed එක යනකොට. Okay, but I will do that. Okay. Right under this, another topic. What is an external unbalanced force? What is an external unbalanced force? It is a topic, okay? It is a topic. Right under that, an unbalanced force means a force which is not balanced. A force which is not balanced. topic was what is the external unbalanced force? What is an external unbalanced force? Topic. What is an external unbalanced force? That is the topic. Right under the topic. And unbalanced force means a force which is not balanced. Which is not balanced. That means if there are external forces, acting on an object, if there are external forces acting on an object, those forces are not balanced. Those forces are not balanced. That means their resultant is not zero. Their resultant is not zero. Therefore, simply we can say an unbalanced force is equal to a force system with non-zero resultant force. Okay, we can write this one and highlight that one. An unbalanced force is equal a force system with non-zero resultant. Okay, like this one. An unbalanced force is equal a force system with non-zero resultant. Okay. Again, what does Newton first law say though? What is the first law again? It is stated about Balanced condition. Balanced conditions means no unbalanced force condition. So if there is no external unbalanced force, what will happen to an object? Look at the argument. What does that mean? If there is no any external unbalanced force, if there is no any external unbalanced force, what will happen to an object? That is stated in Newton's first law. No unbalanced force condition. So if there is no unbalanced force condition, if there is no unbalanced force, no external unbalanced force condition. So if there is no external unbalanced force condition, there may be two cases. There may be two cases. What are those? No external unbalanced force means there may be no forces. No, there may that object doesn't have any external force. That means this one. No forces. No forces are active. No forces acting on that object. No force condition. Or if there are any forces, if there are any external forces, those should be balanced. Those should be balanced. 5 Newton here, 5 Newton here. So no external unbalanced force conditions means there may be two cases, either no force condition or balance force condition, zero resultant condition. Okay. Do you get my point? Do you get my point, everyone? I need your responses.
Yes, sir.
Therefore, Newton's first law is discussed about this condition. If this condition is happened, what will happen to an object? According to Newton's first law, he said, if this condition is happened, then definitely that object, the current condition of that object won't be changed. If it is at rest, it will remain at rest. If it is moving at a constant speed, its constant speed will remain unchanged. That is the condition. Okay. Okay. You have written this one, no? Please give me a thumb if you write this one. Thank you. So I will clean the board. Okay. Please draw these four images. Please draw these four images under that paragraph. Okay. Like that. Unbalanced condition. Okay. Right under that. Right under that.
So give a second, sir.
Okay. This is unbalanced condition, balanced condition, although there are forces. This is balance, this is balanced condition, unbalanced condition, this is balanced condition, no force condition. Although there are forces. Okay. Right under that. Newton's first law. Newton's first law Newton's first law states the condition of an object, the condition of an object when there is no external unbalanced force condition. When there is no external unbalanced condition. Okay. Newton's first law, I will repeat that again. Newton's first law states the condition Newton's first law states the condition of an object Newton's first law states the condition of an object when there is no an external unbalanced force. There's no an external unbalanced force. There's no an external unbalanced force is acting on the object. Okay. Write in a new paragraph. Sorry. Write in a new paragraph. If there is no an external unbalanced force, if there is no an external unbalanced force no external unbalanced force exerted on an object exerted on an object then either one of the following states either one of the following states can occur. Either one of the following states can occur. This one, no external unbalanced force. If there is if there is no external unbalanced force, the object may not have a force. Okay, or if it has forces, it may. So if there are forces acting on the object, those forces should be balanced. So Newton's first law, it states these kind of conditions.
Sir, can you please repeat that? Sir?
Sorry about that?
Sir, can you please repeat that? Sir? After these two states can occur after that.
No. Once you write complete that paragraph, you have to do this one.
Okay, okay, sir.
And we are going to just telling you. Okay.
Okay, sir.
So sorry, actually we don't mention that one. No. Once you complete that one, that means either one of these two conditions can occur. No? The last sentence.
Yes, sir.
After writing that one, please do this one. Okay. Right under this, right under this. While Walker may have a drawing like and the Michigan put it under the other and the okay. Right under this. Therefore, Newton's first law. Therefore, Newton's first law it states about the above two conditions. The above two conditions. Everyone, I need your attention. Marlon. Everyone, I need your attention. Attention, please. Okay, look at the board again. So the Newton's first law. What is it? What does it may say? It states if there's no force, no unbalanced force, no external unbalanced force, if there's no external unbalanced force, what will happen to an object? What will happen to an object? If there is no external unbalanced force to the, you say the current condition, current state of an object, current mechanical state on an object will remain unchanged, or it doesn't change. Okay, so if an object is at rest, it will remain at rest. If an object is moving at a constant speed or uniform speed, it will remain unchanged. So that is the thing we have to extract from that law. Did you get my point? Therefore, from Newton's first law, we can get the most important thing is the most important thing is if there is no external unbalanced force, the current state of an object will remain unchanged. Okay. So now we can write the conclusion of Newton's first law. Write a topic. Conclusion of Newton's first law. Conclusion of Newton's first law. Conclusion. Okay, write the conclusion. Okay, write on this. If there is no external unbalanced force, if there is no external unbalanced force, acting on an object, if there is no external unbalanced force acting on an object, the current state the current state, the current state current state within bracket the present condition close the bracket of the object I will repeat that again. What they say. If there is no external unbalanced force, if there is no an external unbalanced force acting on an object, if there is no external unbalanced force acting on an object, the current state within the brackets the present condition close bracket the current state of the object will remain unchanged. That is a conclusion. If there is no any external forces, then definitely its current condition remains unchanged or it won't be changed. Okay. Okay. Alright. Everyone, I need your attention now. All this 10 plus 8, 10 plus 8. Alright. Now we have discussed about the first law. Do you have any questions to ask? Or did you get my points? All my points? Did you understand that? Please give me your responses. Others? I need responses from everyone. Others? Thank you, Vita. මොකද මෙහෙම කිව්වොත් ඇත්තටම අපි මේ අපි ඔයගොල්ලෝ ඕලල් කාලේ මේවා නිකන් සාමාන්‍යයෙන් මේ ඔයගොල්ලෝ ස්ටඩි කරන්න නැති. ඕලල් කාලේ ගොඩක් වෙලාවට ඔගේ මේක විතරයි අහන්නේ මේ ඩෙෆිනිෂන් එක ඩිස්කස් ලෝ එක ලියන්න තමයි තියෙන්නේ. හැබැයි මේ ලෝ එක ඇප්ලයි කරන්න අපි ඉගෙන ගන්නවා. මේ ලෝ එක ඇප්ලයි කරන්න තේරුම් ගන්න ලෝ එක මොකද්ද මේ කියන්නේ මෙයාට. මොකක්ද මේ කියන්නේ? හොඳට තේරුම් ගන්න කියන්නේ මොකද්ද? එක්ස්ටර්නල් ෆෝර්ස් එකක් නැත්තම් මෙයාගේ ස්ටේට් එක වෙනස් වෙන්නේ නැහැ. එන ස්ටේට් එක වෙනස් වෙලා නැත්තම් මොකක්ද ඔබ්ජෙක්ට් එක there is no any external force. No any unbalanced external force. External force එක තියෙන පුළුවන් balance වෙනවා. හරි. ඒ නිසා අන්න ඒක හරියට තේරුම් ගන්න ඕනේ. මම මේක descriptive විදිහට මම මේක විස්තර කරනවා. හරි. ඒ නිසා හොඳට තේරුම් ගන්න අපි ඊළඟට නිව්ටන් සෙකන්ඩ් ලෝ කතා කරනවා. නිව්ටන් සෙකන්ඩ් ලෝ එකත් අපි විදිහට descriptive විදිහට කරනවා. So you have to understand each and every term in that particular law. To understand that law fully. Okay. එහෙනම් අපිට අද කොහොමද කරන්න වෙන්නේ නැහැ මම හිතන්නේ වෙක්ටර් රූට් එක වැඩක් නැහැ ඉතින් ගෝලේ ටික කරලා ඉවරයිනේ වෙක්ටර් රූට් එක. හරි. කවන්න දැන් එහෙනම් අපි ඉන්ටර්වල් එකක් කරගමු. So you can get a small break now. Now 10 past 10 not straight. Yeah. 10 past 10. Okay. Okay. We can start 10:30. We can start 10:30. Log out and on how in the Mula. Sorry. Break that time. Okay. Then we can discuss about Newton's second law and third law. Then we can complete Newton's law in today's class. Okay. Okay. All good. We have done Newton's first law. We have done Newton's first law. Then now we have to do the Newton's second law. Title topic: Newton's second law. Newton's second law. Okay. In Newton's first law, we have discussed if there is no an external unbalanced force acting on an object, what will happen to the object? If there is no an external unbalanced force, what will be the condition of that object? So that is the content, or that is the content of the Newton's first law. So after that, Newton has discussed if there is an external force, if there is an external unbalanced force acting on an object, then what will happen? Look at that. It is very logical, no? It is very logical. In Newton's first law, he said, if there is no forces, if there is no any external unbalanced forces, what would be the condition of an object? Then after that, he discussed if there is an external force, external unbalanced force, then what will happen to the object? But look at that. It is very logical. It is very logical. Okay. Link to unbalanced force and then unbalanced force. Okay. So first we have to write the top, write the law. Law discuss. Okay. The external unbalanced force. The external unbalanced force. The external unbalanced force. The external unbalanced force exerted on an object. Exerted on an object is directly proportional to the rate of change, in momentum rate of change in momentum of the object. The external unbalanced force exerted on object is directly Proportional to the rate of change. Momentum. Okay. This is the law. So according to the law, if there is an external unbalanced force, if there is an external unbalanced force acting on an object, that force is directly proportional to the rate of change in momentum. How to understand that? How to understand this law? If you want to understand any law, as I said earlier, you have to have very clear understanding about each and every term in that law. You have to have very good, very clear understanding about each and every term in that law. So if you have clear understanding, then you can understand the law. Otherwise, you cannot. Otherwise, you have to remember that thing. So don't remember the law. You have to fully understand about the law. Look at the first word. The external unbalanced force. External unbalanced force, no? Force level. External unbalanced force. So you have to have that understanding. What is an external unbalanced force? We have discussed that thing, external unbalanced force. So I am not going to explain that thing again. An external unbalanced force means the external force, an external force which is resultant is not zero, which is resultant is not zero. That is the meaning of external unbalanced force. Unbalanced force exerted on an object is directly proportional. So what does that mean? Directly proportional. The next term, directly proportional. What does that mean? Tell me. Directly proportional. So what is the meaning of directly proportionality? Directly proportionality. What are the directly proportional? Tell me. Go.
If one side increases, the other side will also increase in the same ratio.
So what is what is the meaning of directly proportionality? Look at this. Look at these two instances. This is first one. This is second one. Okay. One side increases, other side also increases. There is 1, 2, 3, 4, 5, 6. 1, 2, 3, 2, 4, 6. Okay, this is the case 1 and this is case 2. What is the directly proportional case? Is it case 1? Is it case 2 or both cases? 1, 2, 3, 4, 5, 6. So this is 1, 2, 3, 2, 4, 6. Others? Case 1 or case 2 or both cases? You can choose either.
Case 2.
Why? What about case 1? When x increases, y also increases. Why you didn't choose that one? the definition of directly proportional is if the ratio of two quantities is constant. The ratio means x over y, x over y over x. The ratio of two quantities is a constant. They are said to be in a directly proportionality. Constant. What the constant? The ratio means x over y or y over x should be a constant, Puta. Should be a constant. Don't say when x increases, y also increases. You can say that one. But yeah, constant. Look at this. X over y means 0.5. No? In here, x over y means 0.5. 1 over 2 means 4.5. Here, x over y means again 0.5. Look at this. X over y means again 0.5. That means if the ratio between two quantities, is a constant, then they are directly proportional. They are directly proportional to each other. In this case, look at this. X over y means 1 over 4. In here, x over y means 2 over 5. X over y means 3 over 2, 6 means half. So x over y, the ratio is not a constant here. It is not a constant here. Although when x increases, y increases, the ratio x over y is not a constant. But here, x over y is a constant. Therefore, we can write it as x over y is a constant. Fair enough? I need responses from everyone.
Yes, sir.
Others? Therefore, if any two quantities are directly proportional, that means the ratio of those quantities should be a constant. K is constant. Okay. Then look at this. Normally, if two quantities are directly proportional, we represent it as this one. This is the symbol. This is the symbol of directly proportionality. X directly proportional y. Okay. Then we can say if they are directly proportional to each other, x over y means the ratio is a constant. Therefore, x is equal to ky. No? If I do cross product here, f is equal to ky. So this is the relationship. What is the relationship? X directly proportional to y. So I can convert this relationship into an equation using the definition. So if I convert this into an equation, it is equal x equal ky. I have converted this relationship into an equation. අපි කරා මතකද? අපි කරා මතකද මේ unit animations වල? We have converted this relationship into an equation. In this case, I have used the definition. Okay. So this is about directly proportionality. What about indirect proportionality? For inverse proportionality? Inverse proportionality?
The product of x and y should
Yes, very good. Product. In this case, the ratio is constant if the product of two quantities, if the product of two quantities is a constant, then they are in a inverse proportionality. Indirect proportionality, inverse one. Product is a constant. Here, ratio is a constant. Here, product is a constant. Normally, we represent that relationship like this. X inversely proportional to y. X inversely proportional y is represented using this one. Symbol is same symbol, but here normally we write 1 over y, 1 over y, the reciprocal of y. Okay. So if there is this kind of relationship, I can use its definition. No, I can use its definition and we convert this into a equality equation. If there is this kind of relationship, that means the product is a constant. Okay. දැන් මොකද වෙන්නේ? මම ඇත්තම කියනවා දැන් ඔය වෙලා තියෙන දේ ඔක නෙවෙයි. වෙලා තියෙන්නේ මේකයි. දැන් මේක දිහා බැලුවා. නේ? මෙතන මේ මාළුවෙක් ඉන්නවා. මේ මාළුවා අයින් කරන්න පුතේ equal k දැම්මා. මෙතන මේ මාළුවෙක් ඉන්නවා. මාළුවා අයින් කරන්න දැන් මෙයා මෙතන x equal k into 1 over y නේ. මේක මම මෙතන ගෙච්චොත් x equal k times 1 over y. ඒ කියන්නේ බලන්න වෙලා තියෙන දේ. So if there is this kind of relationship, I can convert it into an equation. X equal ky. Actually, I have used the definition of that. No, if there is this kind of relationship, that means it is a direct proportionality. That means x over y is a constant. Therefore, x equal ky. If there is this kind of relationship, that means the product of x and y is a constant. Therefore, I can write x equal k 1 over y. Okay? If I do the cross product here, x equal k 1 over y. No? දැන් ඕක මෙන්න මෙහෙම මතක තියාගන්නවා. ඒක කියා දෙනවා තුන මතක තියාගන්නවා නේද? කියා දෙනවා. මේ වගේ මාළුවෙක් හිටියොත් මාළු වයින් කරන්න පුළුවන් පුතේ සමානයි k දාලා. ඒ කියන්නේ proportional symbol එක අයින් කරන්න පුළුවන් equal k කියලා එකක් දාලා අයින් කරන්න පුළුවන් කියලා කියන්නේ. පට්ට බොන් තර්කයක් නේ. හරි. ඔය වගේ logical නැති දේවල් නම් ඔළුවේ තියන්න එපා. හරිද? මෙන්න logic එක. මේ logic එක නිසා තමයි මේක වෙන්නේ. මේ symbol එක equal k වෙන්නේ logic එක මේක. හරිද? මතක තියාගත්තොත් කමක් නැහැ. logic එක නොදැන මතක තියාගෙන ඉන්න එපා. අන්න එකයි තියෙන්නේ. දැන් මේක අග්ගාල උත්තරේ ගන්න ඕන කමට මේක මතක තියාගත්තා කියලා කිසිම ගැටලුවක් නැහැ. right part එන්නේ. හැබැයි logic එක තේරුම් ගන්න. logic එක නැතුව අර මේ මාළු වයින් කරන සමානයි කියලා දාම එහෙම නම් මතක තියාගන්න එපා උඹේ. මේ වගේ ශිෂ්‍යත ළමයි. හරි. දැන් උගල ලෙවල් කරලා ළමයි උඹේ. ඒ නිසා මේ logically මතක තියාගන්න. හරි. දැන් නිකන් බලන්න නිව්ටන්ස් සෙකන්ඩ් ලෝ එක කියන්නේ කියලා අපි කොච්චර දේවල් කතා කරලාද කියන්නේ. Okay. Let's go to the law again. So in this case, it is mentioned the external unbalanced source, external unbalanced object is directly proportional. It is directly proportional to what? The rate of change in momentum. The next word, the rate of change in momentum. What does that mean? The rate of change in momentum. To understand that thing, you have to have clear understanding about momentum first. So what is the term of momentum? What is momentum? What is momentum? What is momentum? The external unbalanced force is directly proportional. Is direct proportional to the rate of change in momentum. The rate of change in momentum. So what is the meaning of momentum? Momentum කියන්නේ මොකක්ද? Okay. අපි එක බලමු. මෙතන ලියාගන්න. Okay. Right under the law, right under the law. You have written the law, right under the law. Newton's first law. Newton's first law states, Newton's first law states the condition of an object, when there is no external unbalanced force. External unbalanced force. Okay. Plug in another paragraph. Newton's second law it's sorry.
So can you repeat?
First paragraph or second paragraph?
So Newton's first law states the condition of an object, and after that.
Newton's first law states the condition of an object when there is no external unbalanced force. There's no external unbalanced force. The second paragraph. Newton's second law it states the condition of an object when an external unbalanced force, when an external unbalanced force is applied. Okay. Okay. Now we have to define, or now we have to describe each and every terms in that particular law. But we already know about what is an external unbalanced force. We have discussed the theme, and directly proportionality we have discussed the theme previously. Therefore, those things were given. Okay. Then we have to discuss about momentum. Momentum. What is a momentum? What is the momentum? Right topic. Right topic. Momentum of an object. Momentum of an object. Momentum. Momentum. ගම්මෙතා අපෙන්. Last point පුතා මේ in sentence in our paragraph form
So, Newton's second law states that
Newton's second law states that the condition of an object, the condition of an object when an external force, external unbalanced force, an external unbalanced force is applied on the object. Is applied on the object.
Thank you, sir. I had a connection.
Okay. Okay. Actually, we have already discussed about what is an external unbalanced force. Then we have done this previously. What is the directly and indirectly inverse proportionality? Okay, I will do that separately. But up to now we have discussed those things. Okay. Then now we have to clarify what is the term of momentum to understand to fully understand the Newton's second law. Momentum. So write a topic, momentum of an object. Momentum of an object. Okay. Suppose there are two cases. Suppose there are two cases. First case is there are two. Suppose there are two lorries. There are two lorries. The mass of two lorries are equal in masses. Both are same masses. But the first lorry is moving with a speed of 1 ms minus 1. The second lorry is moving with a speed 100 ms minus 1, which is a very high speed. This is a slow one. This is a very fast one. Okay. Suppose if you want to stop this lorry, if you try to stop these two lorries, if you want to stop these two lorries, you have to apply a force. So, what is the larger force? In first case or second case? Second case. So you have to apply relatively larger force to stop the second case rather than the first one, no? Because first one has very small forces. Suppose I'm walking. If I'm walking, actually, you can stop me very easily, no? But if I run fast, can you stop me easily? No, you cannot. No, you cannot. If you try to stop me, then definitely you have to apply very large force. Okay? Therefore, if the velocity, so what is the factor changing these two cases? Only the velocity, no? All the others are equal, but there's only one factor, only one factor which is different in two cases. What is that? It is velocity, no? Only the velocity. So that means if any object has higher velocity, then definitely we have to apply large force to stop or to change its motion, no? And now, did you understand that one, everyone? Okay. Therefore, if any object has higher velocity, then definitely we should apply a larger force to change its current condition. Right? It is very hard, no? It is very hard to change its current condition. But in this case, it is very easy to change its current condition. Then again, this is the first one. The second one. Suppose there's a lorry with 100 kg mass and it is moving at a speed of 10 ms minus 1. Then there's another load which is bigger. And its mass is 1000 kg. And it is moving also at a speed 10 ms minus 2. So if we want to stop these two lorries, then what is the harder one? What will be the harder one? First one or second one? First one or second one? Second one, no? If you want to stop these two lorries, therefore you have to apply more force in the second case, no? Because it has a large mass, no? So if you want to change the current condition, of a body of an object which has higher mass, you have to apply a larger force. Or in other words, if any object has higher mass, it is very hard to change its current condition. And therefore, the current condition of an object depends on its velocity and mass. If the velocity is high, if the mass is high, we have to apply very huge force to change its current position, current condition. Okay, now, do you understand that now? Others, I need responses from everyone. Another? You understand? Yes, you?
Yes, sir.
Understood, sir.
Okay, thank you, brother. Then over කතාවක් අහලා තියෙනව නේද? අලියන්ගෙන් බේරෙන්න දුවන්නේ කොහොමද කියන්නේ? අලියෙක් බැරි වෙලාවත් ආවොත් එහෙම වාගේ පස්සෙන් passing වෙනවා කියන්නේ මේ හරියට මේ attack කරන්න යනවා කියන එක. මේ කොහොමද දුවන්නේ? ඈ? නිකන් අහලා තියෙන්නේ. අලියෙක් පස්සෙන් එනකොට එන දුවන්නේ තමයි කියන්නේ. මොන විදිහට දුවද්ද හොඳ? අහලා නැද්ද? අහලා නැද්ද? තාම අලියෙක් පස්සෙන් එනවද නැද්ද? ඇදේට නෙවෙයි zigzag zigzag ඇදේට දුවනවා කියන්නේ ඇදේට දුවත් කෙලින් වෙනවනේ zigzag දුවන්න ඕන zigzag දුවත් zigzag දුවන්නේ කියන හේතුව අලියගේ මෑස් එක වැඩි අලියගේ මෑස් එක වැඩි අලියගේ මෑස් එක වැඩි නිසා එයාගේ කරන්ට් පොසිෂන් එක හරි චේන්ජ් කරන්න ටිකක් අමාරු හරිද ඒ කියන්නේ උන් මේ පැත්තට දුවගෙන ආව අනිත් පැත්තට හැරෙන්න ටිකක් අමාරු උට හරිද ඒකයි දුවනවා නම් දුවන zigzag විදියට දුවන zigzag විදියට එතකොට අර පොඩ්ඩක් හරි බේරෙන්න පුළුවන් ඒ කලියෙදි හරි
It's a smart alien. So what if the elephant is a smart one? What if he keeps on
sorry
running? What if the elephant is a smart one and he keeps on running in like in a straight line and finally will meet again?
then you don't have any chance okay no actually normally we have to run that way but the thing is that depends on the speed of elephants okay if we can control his speed then he can turn easily okay but normally elephants are running very fastly therefore normally elephant cannot change its path very quickly okay therefore anyway if any object has higher mass or higher velocity, it is very hard to change its current condition. Okay. Therefore, this property, there's a property, there's a property, that property, okay, shall I write that one? Okay, momentum. Draw the first one. Draw the first one. Okay. Others? Okay, right under the first image, don't draw the second one. Don't draw the second one, only the first one. Only the first one. Right under the first image. Suppose two lorries of equal masses. Two lorries of equal masses. Two lorries of equal masses are moving at velocities 1 ms minus 1 and 100 ms minus 1. 1 ms minus 1 and 100 ms minus 1. It is obvious, it is obvious, it is obvious, obvious, it is obvious that we have to apply, it is obvious that we have to apply it is obvious that we have to apply a relatively large force, a relatively large force, large force. To stop the second lorry, to stop the second lorry, to stop the second lorry, than that of the first lorry, than that of the first lorry. Okay. Then draw the second one. Then draw the second one. Okay, right under that, right under that. Suppose two lorries having masses 10 kg and 1000 kg, 10 kg and 1000 kg, 10 kg and 1000 kg. Are moving are moving at the same speed. At the same speed. Body are moving at the same velocity at the same velocity. Speed kapan velocity. It is very clear. It is very clear. It is very clear. It is very clear that we have to apply. That we have to apply. That we have to apply. A larger force. A larger force. To stop the second lorry. To stop the second lorry.
So a larger force to stop.
The second lorry. Stop the second lorry. Okay. Look at the board again. Hurry. Okay, look at the board. That means, okay, that means when mass increases, mass and velocity increases, when mass and velocity of an object increases, we have to apply a larger force. We have to apply a larger force to change its current position, current condition. No? So if the mass or velocity increases, then we have to apply a larger force on that object to change its current position, current condition, or current state. Okay. Therefore, the applied force, the required force to change the current condition, depends on the mass and velocity of that object. Mass and velocity of that object. Therefore, there is a property that decides the applied force, and the property depends on mass and velocity. So that property is called as momentum. Actually, we have introduced another special term to that property. Okay, a special term to that property, name to that property. What is that? Momentum. So momentum is the property, or momentum is the physical quantity that decides the required force to change the current condition of an object. Okay. Look at this again. So momentum is the physical quantity, or momentum is the quantity that decides. You take the decision. Okay. Momentum is the physical quantity that decides the required force to change the current condition or current state of an object. Okay. Therefore, momentum depends on mass and velocity. Mass and velocity. When mass increases, momentum also increases. When velocity increases, momentum also increases. Okay. Therefore, we have defined momentum. We have introduced a special name. Okay. We have introduced a special name. That name is momentum. That term, that physical quantity depends on mass and velocity. Mass and velocity. So the importance of this property is this is the deciding factor. This is the deciding factor of external force, which is required to change the current state of an object. Did you understand? Fair or not? Did you get my point? No. Okay. So actually, external force apply external force depend mass velocity mass then only external force velocity then only external force value. Therefore, we have introduced another special term to that thing. That term is momentum. So momentum depends on mass and velocity. Okay. නිසා මට mass එක velocity වෙන වෙනම consider කරන්න වෙනකොට මට මේ එක term එක consider කරන්න පුළුවන්. ඒකයි මෙතන එක term එකක් introduce කරා. හරි. එක term එකක් introduce කරා. That is equal to mass into velocity, because when mass increases, P also increases. When V increases, P also increases. Therefore, instead of considering two quantities separately, we can consider this physical point, that means momentum. We can consider momentum. When the momentum of an object increases, that means it is required larger force to change its current condition. Okay. අතර මෙතන කරේ මෙතන ඕනනම් මට වෙන වෙනම හිතන්න පුළුවන් mass එක velocity වෙන වෙනම හිතන්න පුළුවන්. මෙතන එකම කරයි. ඊට වඩා ලේසි මට mass එක velocity combine කරලා combine කරපු quantity එකක් හදාගන්න. මෙතන කරේ ඒක. So instead of considering mass and velocity separately, now I can consider the momentum. If momentum increases, that means one of those three property or both property has increased. Okay. So I just want to consider about momentum. When momentum increases, definitely we have to apply larger force. Okay. Fair enough? Are you clear with that? Everyone, I need responses. So momentum is the force. No, momentum is not the force, Buddha. It is not the force. It is not the force. It is the property that decide the external force which is used to change the current position of an object. Okay. So momentum is the deciding factor. Momentum is the deciding factor of external unbalanced force required to change the current condition of an object. Okay. When mass increases, we have to apply huge force, no? We have to apply huge force to stop that thing. No? Stop, don't may say stopping, change the condition. Okay, we have to apply huge force to change its current condition. When velocity increases, we have to apply huge force to change its current condition. Don't say stopping, because not only stopping, we can change its current condition. So mass and velocity, actually mass and velocity are the two quantities that decide the required force to change the current condition. Okay, so but actually we have to consider mass and velocity, then we have to consider the mass and velocity separately. So instead of separate consideration, I have introduced new term or new physical quantity, which name is momentum, that depends on mass and velocity. So when mass increases, momentum also increases. When velocity increases, momentum also increases. Therefore, instead of considering mass and velocity separately, now I can consider this term, momentum. When momentum increases, definitely mass or velocity or both has been increased. No? Therefore, it is required larger force to change its current position. Then, people. Did you understand? Okay. Okay. Right on the writing new paragraph. Okay. Therefore, it is clear, therefore, it is clear that when mass and velocity, when the mass and velocity of an object increase. More external force, large external force is required Okay, I will repeat it again. Therefore, it is very clear that when the mass and velocity of an object, when mass and velocity of an object increase, a large external force is required to change the current condition, the current state of the object. Thus, the external force required depends on mass and velocity. Write it in another paragraph, new paragraph. Therefore, this property of an object, that decides the external force, to be applied is called as momentum. Momentum is called as momentum. Momentum is called as momentum. 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 Normally we represent it as P. P is equal mv. M is mass into velocity. Mass into velocity. P equal mv. What about Okay, look at this. P equal mv, no? You can clearly see m means mass. Mass is a scalar. This is scalar. Scalar quantity. Scalar quantity. This one, velocity. Velocity is a vector quantity. Velocity is a vector quantity. Actually, we have discussed about vector multiplication, no? Vector multiplication. So when a vector is multiplied by another physical quantity, a vector is multiplied by another physical quantity, we will have new physical quantity, new vector quantity, new vector quantity. This is not equal to velocity. This is another velocity. This is another vector quantity. So if any vector quantity, look at this, if any vector quantity, if any vector is multiplied by another physical quantity, this is not a number, this is another physical quantity. Mass is another physical quantity, no? Another scalar quantity. Another scalar quantity, we will have new vector. Okay. F equal ma, no? F equal ma. A is multiplied by A is multiplied by m, no? A is acceleration, it is multiplied by mass. If A is multiplied by mass, you will have another vector quantity which is force. No, it is force. Okay, therefore, if a vector quantity is multiplied by a physical quantity, another scalar physical quantity, we will have a new vector quantity. So P, momentum, is a vector quantity. The direction of momentum is equal to the direction of velocity. Direction of velocity. Because this is a scalar, so it doesn't have a direction. This is the only quantity that has a direction. So direction of P is equal to direction of velocity. Direction of velocity. Okay. Write down, you see. Okay. Right under this, right under this. Therefore, momentum is a vector quantity. Momentum is a vector quantity. Momentum is a vector quantity. Then that is the first star mark. The second star mark. The second star mark. The direction of momentum. The direction of momentum. The direction of momentum is equal to the direction of velocity. Is equal to the direction of velocity. The third star mark unit. Unit is equal kilogram ms minus 1, or we can simply say Newton second. Newton second.
So what was the second?
Sorry.
So
Second.
what was the second point? Yes.
Second. First star mark is first star mark is momentum is a vector quantity. The second star mark is the direction of momentum. The direction of momentum is equal to the direction of velocity. The direction of momentum is equal to the direction of velocity. Sorry. The direction of momentum is equal to the direction of velocity. Third star mark is unit. Unit is equal kilogram ms minus 1 for Newton s. When you are writing this unit, you have to keep one gap here. Okay, one gap here. Kilogram is one physical quantity. Meter is another one. Second is another one. You have to keep a gap. You have to keep a gap here also. Newton and s. You have to keep a gap. Newton is capital N, simple S. Okay. You have to maintain those things. Okay. Okay. Do you have any questions up to now? Or are you clear with all the things? Yeah, number. Oh, I need responses. Are you clear with all the things, or do you have any questions? Thank you. Thank you. Okay. Okay. Please go through the notes. Please go through the note, or once I upload the video, you can watch that also. Please go through it again. So if you have any questions to ask, please ask before the next class. Okay. Another thing, please send me your note as well as your answers for vector lessons as quick as possible. Okay. Now you can send the let me note of with positive, okay? Because now we have done it that. So please send that. After that, please complete MCQ of vector lesson within 2 hours and send the answer sheets to me. Okay? Answer sheet mean not only the answers, but also you have to send me the way of you do the summation. Okay. Okay. So send that to me. Then again, you will have to do you have to do another evaluation. I will give you another lesson on that. After that, we can do evaluation. Okay. 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 Today, now we are going to complete our class today. So, everyone, have a nice day. I want.
I also thank you.
Thank you, sir. God bless you.
God bless you, Sudha. Welcome, Sudha.